Today we are going to talk about negative and zero exponents. And the first thing we are going to touch base with is zero power. Every time you have a number to the zero power, it's equal to 1. When you look back at our ballot activity, when we were cutting one piece of paper into 3 ballots, before we made any cuts, when we had 0 cuts made, we had 1 ballot. And that's why 3, that was the number of cuts we were going to make before we made any cuts at 0 power, was equal to 1. If we have even, doesn't matter what number, even huge number like 5,398,763 to the 0 power, that's still equal 1. And then x to the 0 power, again, equal 1. Another thing that we need to look at is negative exponents. From our activity with the tables, we recognize that whenever we had a negative exponent, we could rewrite it as a reciprocal of that power with a positive exponent. So 4 to the negative second power would be 1 over 4 to the positive second power. 10 to the negative third power would be 1 over 10 to the positive third power. X to the negative third power is equal to 1 over x to the positive third power. So from now on, if our final answer has a negative exponent, we need to make sure to rewrite it as a reciprocal of that power with a positive exponent. So here are some examples. Number 1, we have 3 to the 5th times 3 to the negative 7th power. We are multiplying two powers with the same basis, so we need to add the exponents. So 5 plus a negative 7 will give us negative 2, and because our last answer is with a negative exponent, we need to rewrite it as a reciprocal of the same power with a positive exponent. Second example, n to the 6th power times n to the negative 2nd power. So we are multiplying two powers with the same basis, which means we need to add the exponent. So we have 6 plus negative 2, which will give us n to the 4th power. Because this exponent is already positive, we don't need to worry about rewriting anything with positive exponent. Let's look at the next example. 4 to the negative 2nd power divide by 4 to the 3rd power. When we divide two powers with the same base, we simply subtract the exponents. So we have the exponent of numerator minus the exponent of the denominator. Negative 2 minus 3 will give us negative 5. Because final answer is negative exponent, we need to rewrite it as a reciprocal of that power with a positive exponent. X to the 5th divided by x to the negative 1st power. Again, we need to subtract the exponent, which will be 5 minus negative 1. So don't forget that. I should not drop that negative in front of 1. So 5 minus negative 1 would be the same as 5 plus 1, which will give me 6. Because the exponent is already positive, I don't need to worry about rewriting it as positive exponent. So now let's look at raising power to power. So we have 11 to the 0 power risen to the 5th power. When we raise power to power, we multiply the exponents. 0 times 5 is 0. Any number to 0 power is equal 1, so my final answer is 1. Y to the negative 5th power risen to the 2nd power. I need to multiply the exponents, so I have negative 5 times 2, which will give me exponent of negative 10, but I cannot leave negative exponent, so I need to write it as the reciprocal of the same power with a positive exponent.